In this video, we're going to discuss reaction rates. Reactions must take place when one particle interacts with another particle through a collision. So these must collide, and they must come in close enough proximity to each other that their electrons interact. And so various different things will affect how fast the reactions occur. The first thing that affects these types of reactions would be concentration. The higher the concentration, the faster the reaction is going to occur, because the more of these particles there are and the closer together they're packed, the faster they're going to run into each other and the more often they're going to hit. So the higher the reaction rate, the faster the reaction is occurring. There's several things that will increase the reaction rate. The first one is the higher the concentration, the faster the reaction. Or we could say the higher the rate. The second thing is increasing the temperature. So the higher the temperature, the faster these particles are moving as they are zooming back and forth to hit each other. And of course, the faster that they're going, the farther the distance that they travel, and the more likely that they are to run into each other. You get more collisions the faster you're going. Imagine that it's like bumper cars. In your bumper cars, the faster your bumper car goes, the more other cars it's going to hit. And if all the cars are going very fast and you're still in a very contained area, the more collisions you're going to have. The more collisions you have, the more energetic those collisions are, the more reactions you're going to have, the more molecules are going to start changing because of the collisions, and the faster your reaction rate is going to go. So another thing that's going to affect your reaction rate is going to be surface area. So increasing the temperature increases the rate, and also surface area increasing also increases the rate. Now, what does surface area have to do with this? The final thing that affects the rate of a reaction is called a catalyst. And a catalyst will also increase rate. In another video, we discussed cellular respiration. Cellular respiration is the conversion of glucose with oxygen to carbon dioxide plus water. I noted in the earlier video, and I'll note again now, that this looks very much like a combustion reaction. But in a combustion reaction, in order to get this reaction to go as a combustion reaction, and you can actually take glucose and burn it in a combustion reaction, but you have to add a significant amount of heat. You have to light it somehow. And usually this would be done by heating it to quite a high temperature in order to get this reaction to occur. In our cells, this reaction occurs without that very large amount of energy being dumped into it. So if we were going to do it as a combustion reaction, we would have to hit a certain amount of energy. If this is the energy of the reactants, and here's the energy of the products, and then the intervening energy between here and the products is the amount that's going to be released, which is very good for cellular respiration. And this top one would be the amount of energy that is required to activate the reaction, or the activation energy. So if we were talking about doing a combustion reaction, this would be the energy provided by the match or whatever heating implement that we used to heat the glucose and oxygen together to get them to collide with sufficient energy to have the chemical reaction occur. However, in our cells, this occurs as cellular respiration, and we don't raise our body temperatures or any temperature in our body to the equivalent of fire in order to get this reaction to occur. So it will occur at a much lower activation energy, still releasing energy, however, due to a series of catalysts. And these catalysts, because they're biological catalysts, we call them enzymes. Now, enzymes are what nature uses for catalysis, and a catalyst is something that lowers the activation energy of the reaction in some way. Catalysts are not used up or damaged in a reaction. If they do react in any way, they're regenerated. So usually your catalyst has a certain amount of turnover rate. In other words, there's so many reactions that a catalyst can catalyze before it stops working. And with enzymes, that's a really, really huge turnover rate. And it also refers to how many reactions that catalyst can speed up in a given amount of time.